Lesson 38, powers of sums, solving by factoring, and only 0 equals 0. Let's start off with powers of sums. In powers of sums, all we're doing is taking a binomial and distributing it to the specified power. Distribute the binomial to the specified power. For example, if we have the binomial x plus 3 to the third power, this means that we're multiplying x plus 3 times x plus 3 times x plus 3. What we're going to do is distribute in order to come up with a solution. Now we can't distribute all three at once, so we're going to deal with the first two binomial pairs first. So let's distribute. X times x is x squared. X times 3 is 3x. 3 times x is 3x. And 3 times 3 is 9. So we distributed the first two pairs. If we combine like terms, we end up with x squared plus 6x plus 9. That was x plus 3 squared. Now we need to multiply by another x plus 3 term in order to take it to the third power. So we're going to multiply x squared plus 6x plus 9 times x plus 3. We're going to do this by distributing the same way that we did before. X squared times x is x cubed. 6x times x is 6x squared. 9 times x is 9x. X squared times 3 is 3x squared. 6x times 3 is 18x. And 9 times 3 is 27. Once we've distributed completely, we combine like terms. X cubed, and we have two x squared terms which are going to combine to be 9x squared. We have two x terms which will combine to be 27x, and plus 27 is at the bottom. So powers of sums is simply using the distributive property to distribute each binomial to the specified power. Let's go ahead and try another example. X plus 2 cubed. Pause the video and try this on your own. When you come up with a solution, hit play. Alright, let's distribute to find our solution. We should have distributed the first two binomial pairs first. We should have gotten x squared plus 4x plus 4. When we distribute that times another x plus 2 term, we should have come up with x cubed plus 4x squared plus 4x plus 2x squared plus 8x plus 8. And when we combine like terms, we should have ended up with x cubed plus 6x squared plus 12x plus 8. This is the final solution. Moving on, we're going to talk about solving by factoring. Along with this goes only 0 equals 0. We've been doing a lot of problems where we have an x squared term followed by an x term followed by a constant. Our goal now in these problems, instead of simply factoring, is to come up with a solution for x. We're trying to solve for what x equals. In order to solve what x equals, we need to do a few steps. Step 1. Rearrange the problem to descending powers. set the equation equal to 0. Step 3, factor. Step 4, set each factored pair equal to 0 and solve for x. Step 1, rearrange the problem to descending powers. Step 2, set the equation equal to 0. Step 3, factor. Step 4, set each factored pair equal to 0 and solve for x. Let's do some examples. Example 1, negative x plus x squared equals 6. First step is to rearrange the problem into descending powers. So we want the greatest power to come first. The greatest power is x squared. So x squared comes first. The x term follows. So we bring down our minus x. We want this 6 constant to be on the other side of the equal sign. So we're going to subtract it from both sides and get minus 6. So now that we've written it in descending order, it's x squared minus x minus 6. Step 2, we're going to set the equation equal to 0. So we're going to take the entire thing and make it equal to 0. Step 3 is to factor. We're going to factor this trinomial to 2 binomial pairs. First term is going to be x because x times x gives me x squared. In order to find the last term, I want to know what numbers multiply to give me 6, but add or subtract to give me 1. 3 times 2 is 6. 3 minus 2 is 1. The 3 is going to be negative, and the 2 is going to be positive. So we factor. Step 4 is to take each pair and set it equal to 0. So x minus 3 is going to be equal to 0, and x plus 2 is going to be equal to 0. Now that we have two equations, we can solve for x. So in our first equation, x minus 3 equals 0, x is going to be equal to 3, because 3 minus 3 equals 0. This is where 0 only equals 0 comes into play. If I was to do 3 minus 3, that would be 0, and 0 is equal to 0. Over here, we have x plus 2 equals 0. Therefore, x is going to be equal to negative 2. So our two solutions for this equation is x equals 3 and x equals negative 2. Let's try another example together. Negative 35x equals negative 2x squared minus x cubed. The first step is to put this in rearrange it in descending order of exponents. X cubed is our biggest exponent, so we're going to move it to the other side of the equal sign to make it a positive x cubed. X squared is our next term. We're going to move it to the other side of the equal sign to give it a positive 2x squared. And negative 35x is our last term. Now we've written it in descending order. The next thing we're going to do is set the equation equal to 0. Then we're going to factor. Now notice in this problem that we don't have just a trinomial that is to the power of 2. We have a trinomial that's to the power of 3, and each term has an x in it. So we're going to factor that x out first. When we factor an x out, we're left with x times x squared plus 2x minus 35. Keep in mind that this whole equation is still equal to 0. Now we want to factor to two binomial terms. So we're going to factor x squared plus 2x minus 35 into two binomials. The first term is going to be x. And we're looking for numbers that multiply to give me 35, but add or subtract to give me 2. And that would be 7 and 5. 7 is going to be positive and 5 is going to be negative. Now, we have x times x minus 7 plus 7 times x minus 5. And all three of these are going to be equal to 0. Whatever your greatest power is, in this case it's cubed, is how many solutions you're going to have. Now we notice that each binomial equal to 0. So we have x plus 7 equals 0 and x minus 5 equals 0. But we also have this x that's hanging out outside by itself. That x alone is going to be equal to 0. So that's actually one of the solutions, x equals 0. When we have x plus 7 equals 0, that x is going to be negative 7. And when we have x minus 5 equals 0, that x is equal to 5. So x equals 0, 5, and negative 7 in this solution. Let's do one more example. This example I want you to try on your own. 2x squared plus 4x minus 70 equals 0. This one is already rearranged for you in descending order. However, you will have to factor something out before you can factor down the two binomial pairs. Pause the video and try it yourself. And hopefully in this problem that you've noticed that 2 goes into each term. So we can factor a 2 out. When we factor out a 2, we're left with x squared plus 2x minus 35. The whole thing is still equal to 0. You'll notice this is very similar to the example number 2. We're going to factor to two binomial terms. We have x plus 7 and x minus 5. This is still equal to 0. Now before, when we had an x out in front, we said that x was equal to 0. Now we have 2 is equal to 0, which is not the case. So 2 cannot be a solution to this equation. We're going to take our other two binomials and set them equal to 0 to find our other solution. X plus 7 equals 0, which means the solution is negative 7. And x minus 5 equals 0, which means that 5 is the solution. So the two solutions to this equation is x equals negative 7 and x equals 5.